Alright guys, so what we're going to look at now is we're going to look at rates of change. So like, the first thing we're going to know is that the first derivative is the rate of change of our function. That's essentially what it's referring to. So it's the rate of change of our function. Now, often this time, the variable is going to be t, and that's going to be the variable you're going to be differentiating. That's why it's dy over dt. Now, the y variable may change as well, depending on what we're going to be looking at, like we're going to see in our first example here. And so you can find the average rate of change, and that's essentially the change in our y over the change in our t. I don't know, I kept just blanking like x and y for a moment there, but that's what the average rate of change is going to be ending up being. So let's take a look at an example here, and this gives us a good indication of how these generally are going to work. So the number of bacteria in a culture increases according to the function b equals 2t to the 4 minus t squared plus 2000, where t is the time in hours. So the first thing you want to do is find the number of bacteria initially. Now that word initially always refers to the value at t is equal to 0. So that's what we're going to do here. We're going to sub 0 into this function here, and we're going to end up with 2000, which means that's the initial amount of bacteria at time is 0. We can go from here. The average rate of change in the number of bacteria between 2 and 3 hours. What we're going to be looking at is the value for B when t is equal to 2 and t is equal to 3. And we can see how it changes to find that rate of change. So when t is 2, we're going to end up with, oh my god, I should have had my calculator. What am I doing? That's fine, we write on. 2 to the power of 4 is 16, times 2 is we have 32, minus 4 plus 2000. So we're going to end up with, let me grab my calculator. I have one sitting right here. Yes, look at it go sideways. I'm like that. I'm not starting again. So we're going to have 2 to the power of 4 minus 2 squared plus 2000, which is 2028, and when t is equal to 3. So we just type those numbers, swap them into the equation. We have 2153, so that the rate of change here is going to be the 2153 minus 2028 over 3 minus 2. So like what we've got here, it's the rate of change. It's essentially asking us to find the gradient manually. And when we type that in, we're going to get minus 2028. It's going to be 125. So that means that the rate of change between hours 2 and 3 is 125 bacteria per hour. So you can look at your units here to determine what they're going to end up being. The number of bacteria after 5 hours. So the number of bacteria after 5 hours, we can essentially do the same thing. When t is equal to 5, b is equal to, we're going to sub 5 into t, press some buttons in our calculator, which I'm doing now, and we get 3,225. The rate at which the number of bacteria is increasing after 5 hours. So that comes back to what we looked at the start. The rate of change will require us to find the first derivative. So that'll be b dash or dB over dt. The first derivative gives the rate of which it is changing at a particular point in time, not the rate of change, the rate of change at that time period. So dB over dt, got to differentiate t to the 4. 4 comes out the front, so it's going to be 4 times 2 times t to the 3 minus 2t to the 1, or just 2t plus 2000. We clean that up, and we end up with, oh, that's gone. Get rid of those whole numbers when you differentiate. That gives us the rate of change. So we want to find the rate of change that's increasing after 5 hours. And so we're going to sub t equals 5 into that first derivative that we've got going on right there, which gives us 990. So that's the rate of change at 5 hours. That is when it is increasing here. So a lot of this, you can see that's really kind of how it works. It works relatively well, and you're essentially just got to make sure that you're paying attention and looking at how the question is written and if there's anything you need to change in regards to that. So looking at the worksheet, a lot of them are going to be just getting you to find the volume for the first question, but the second it wants you to look at the rate at which something is changing at a point in time, that's when you're going to be using the first derivative. And question 6 is really going to get you to walk through all those particular points there. And that's just a little summary look at rates of change.